11s, I hope you are well. Today we'll be covering or we'll be continuing with our practice into trigonometry. So we'll be focusing on strictly trigonometry. So as part of our practice, we'll be covering some of the question papers as you may have seen in the previous videos. Please do ensure that you watch the previous videos, especially those that deal with content specific just content, because it gives you a base. It gives you a base into understanding trigonometry and everything that has to do with trigonometry, so that when we come to our questions, it's just application of understanding what already is happening. And so today we'll be looking at a Johannesburg North paper. It's a final paper, grade 11. Right, so let's get into it. As I've already said, it's going to be question relating to trigonometry. So we'll start at question 5. Right, so here we are being told that if sine p, if sine 19 degrees is equals to p, determine the following in terms of p. It means that all the answers that we get, it should be in terms of p, or they should have some value of p, right? So the first thing that I'm going to start by doing here is, I already know that I have sine of 19 degrees is equals to p, right? Which can also be written as p over 1. And this is the same thing as having your opposite over your hypotenuse, which is the same thing as y over r. So we are going to use this, solve this with the aid of a diagram, right? Even though they didn't say, so we can just write here that we are going to solve with aid of a diagram, right? So that's what we are going to try and do. So this is the first step, right? This is the first step. So basically it means that our y is equals to p, right? And then our r is equals to 1, right? And then we need what? We need x, right? We need x. So therefore, what we are going to do here, we are going to just draw a simple small triangle. We are going to draw a simple small triangle. It's going to be 19 degrees here, right? So let's just take the triangle a little bit down, right? So we already know that y is p, right? So we already know that y is p. We know that r is 1 and x is what we are looking for, right? Remember, this still stays as your right angle triangle. So here we are just going to say r squared is equals to x squared plus y squared, right? And then we can just move on to the next page. So if we have r squared is what? 1 is equals to x squared is what we are looking for, plus what is y? Y is just p squared, right? We are looking for x squared is going to be your p squared minus 1, right? And then from here we can just take the square root, right? So x is just going to be positive square root of p squared minus 1. So in this case, we don't focus on the signs, right? Because we were not told the conditions upon which sine 19 degrees is equals to p. If we were told the conditions upon which this 19 degrees will hold true, then we would have needed to choose the correct sign. So in this case, we are just going to use the positive one. So now we have x, and then we can go ahead and solve this, right? So we'll start with 5.1.1. So 5.1, they want cos of 19 degrees, right? So they want cos of 19 degrees, right? So from our triangle, so we already know that this is your p squared minus 1. So we already know that, right? So we are already told that, we already calculated that, right? So this side is just going to be that. Right. So what is cos of 19 degrees? So cos, looking at this triangle, cos is going to be adjacent over hypotenuse. Adjacent over hypotenuse is the same thing as having x over r, right? So now we know x is just your p squared minus 1 all over r is just 1, and therefore this is just going to be your p squared minus 1, right? And then we stop here, right? So now let's look at question 5.1.2. I guess it's safe to say we can move to the other side. So your question 5.1.2, what they want is tan of negative 559. It's going to be tan into negative 559 degrees, right? Is it that? Yeah, it's tan negative 559, right? So what we are going to try and do, we are going to try and work with this. So we are going to try and write this to have a positive acute angle. So we are going to try to write your negative 559 degrees, right, to a positive acute angle, right, to a positive acute angle. Right, so that is going to assist us into solving this, right? So the way that we are going to do that, right, we are going to say negative 559, right, plus, let's say 2 times your 360 degrees, right? You can try any method, it should still work, right? And then from here, you are just going to have 559 plus your 270 degrees, right? And then this is going to give you what? 161, right? So in this case, we therefore now have your tan, right, into 161 degrees, right? So in this case, we can write this as your tan into 180 minus, for us to get 161, we can just say 180 minus 161, it's going to be 19. We are still dealing with degrees, so it's going to be 19 degrees. So this is going to be your tan of 19 degrees, right? Which then takes us back to okay. This takes us back to our right angle triangle here. So we can just take the triangle and we bring the triangle probably here, right? Let's just make it a little bit smaller. And then from here, if we want your tan of 19 degrees, your tan, what is tan? It's opposite of adjacent. So this is going to be your y over your x, right? So what is y? So y in this case is going to be your p over your p squared minus 1. Right, so this is going to be your answer. This is going to be your answer. Right, so now let's look at the last one, which is 5.1.3. So now you have 5.1.3, and they are saying it's cos squared 71 minus 1. So it's going to be cos squared 71 degrees minus 1. Right, so now what we are going to try and do is we are going to try and find a way in which we can write 71, right, to be 19, right? We are going to try and write 71 to be 19 degrees. So we can just write 71 degrees to be 19 degrees. Right, obviously there's alternative ways in which we can solve that, but yeah, if you are, I'm happy to take you through those ways. So now it's going to be your cos squared into the way in which you can write 71 is going to be 90 degrees. 90 degrees minus 19, right, is equals to, minus 1. So remember, now you have a cofunction, right? Now you are going to have a cofunction. So this cofunction, what this cofunction will represent, right? It's going to be 90 minus. So 90 minus is in the first quadrant. So this is just going to be your sine squared 19 degrees minus 1. Right, so now we want your sine of 19 degrees. So we can still take my angle, my right angle triangle, bring it here. Right, so now I want what? Sine of 19. What is sine of 19 degrees? Oh no. So what is sine of 19 degrees? So sine squared. So sine of 19 degrees, it's opposite over hypotenuse, right? So this is going to be opposite over hypotenuse, which is y over r all squared minus 1. So this now will eventually be, what is y? Y is p over what is r is just 1 squared minus 1. So this is just going to be your p squared minus 1. Right, so this is the answer. So this is the answer. Great. So now we can move on to the other question. So here, what we can just try to do is just take it a little bit up so that, okay, we can just take everything up so that it's just visibly clear. Right. Right. So now let's look at your 5.3. 5.2. So in this case, we need to prove the following identity, right? So we are just going to work with the left-hand side, right? We're just going to work with the left-hand side, and we have the left-hand side, you have 1 over your sine of beta plus 1 over your tan of beta all squared is equals to, okay, we don't have to write the equals to. We just need to make sure that whatever we do, we prove it to be this, right? Great. So what I'm going to do is I'm going to say I have 1 all over my sine of beta plus, what is tan? Tan can also be written as your tan of beta can also be written as your sine of beta over your cos of beta. Right, so that's what I'm going to do. So this is going to be 1 over my sine of beta all over my cos of beta over all over square, all squared, right? So if now, I'll just write this here. If now I have, right, I have 1 over your sine beta over your cos beta. This is the same thing as I can write it as 1, right, times division becomes multiplication, and then the numerator becomes the denominator. So it's going to be your cos of beta over your sine beta. Right, so I will just substitute that, right, which essentially it's the same thing, which essentially is the same thing as your cos of beta over your sine of beta. Right, so I'm just going to go ahead and substitute that, right? So now I'm going to have my 1 over my sine of beta plus your cos of beta over your sine of beta all squared, right? And then from there, I have the same denominator, and then I can just add the numerator. So it's going to be 1 plus your cos beta all over your sine beta all squared, right? So what I can do now, it's quite simple. So I'm just gonna say 1 plus my cos of beta, right, all squared all over your sine squared beta. So I just distributed the squared, right? So I just distributed the squared, and then from there I can just take it to the other side, right? I can just take it to the other side. Remember, this is going to be, let me see, yeah, remember we can change sine squared can be sine minus, it's going to be sine minus that. Now I see. We must remember that this is what we have here. This is what we have. Must always remember what we are trying to prove, right? You must always remember what you are trying to prove. So it means that we can change this to become cos, right? So remember your cos squared beta plus your sine squared beta is the same thing as 1, is equals to 1. Then if we have sine squared beta is the same thing as 1 minus cos squared beta, right? So from there we can just substitute. So we are going to have 1 plus your cos of beta all squared over your 1 minus your cos squared beta, right? So now we have something almost similar to the denominator. We have something almost similar to the denominator. So we need to see how we can solve this now. So this can also be written as 1 plus your cos beta 1 plus your cos beta still, right, all over. So now I need to find a way in which I can write this, right? So 1 minus cos squared beta, right? So 1 minus cos squared beta is going to be the same thing as 1. It's going to be the same thing as 1 minus cos beta into 1 plus cos beta, right? This is the same thing, right? This is the same thing as having 1 minus x squared, which can also be written as 1 minus x, right, into 1 plus x, right? So if you expand the brackets, it's going to be 1. If you do the FOIL, it's going to be 1 plus x minus x minus x squared, right? So this and that will cancel. So we are just going to be left with 1 minus x squared. So what we did there is essentially the same, right? We essentially did the same thing. Great. So now this and that can cancel. So I'm just going to be left with 1 plus your cos of beta all over your 1 minus your cos of beta. So this is going to be my answer, right? And therefore it means that my left hand side is indeed equals to my right hand side. Right. My left hand side is indeed equals to my right hand side. So I got my findings. Right. So now let's look at the next question, right, which is your question 6. So what do we have here? We also have, or we need to simplify this without the use of a calculator, right? And it's 8 marks. So we don't need to make mistakes with this one. Right? So I'm just gonna, I'm not gonna write it again. I'm just gonna go ahead and solve it, right? So your sine of negative x, right, I can just take out the negative sign and then I will have your sine of x times, right, this I can also arrange and say it's negative. I'll just put it in brackets. It's negative tan into 360 degrees, right, minus x. Minus x is going to make x positive, right? Great. And then from there, I need to find a way in which I can write sine 450. So I will come back to that. So I'll just say sine 450 minus x, right, all over cos of 180. Remember, if you take your cast diagram, this is where you will find 180, and 180 is here. And if you are considering a unit circle, here it's 180, so it means that the value here is going to be exactly -1. Right, so cos of 180 is just -1. Right, so we are running out of space, so just try to bring this here, right, and then plus our cos squared into x minus 180 degrees. Right, so now it becomes easy. You have -1, so we can just cancel this and that. So now I'll be left with your sine of x, right, times into minus tan 360 degrees minus x, right, times your sine of 450 minus x, right. I keep on not writing, so I keep on writing very big. and I can still move this to here, and then I still have my plus cos squared into x minus 180 degrees, right? So now if I remember my cast diagram, right? If I remember my cast diagram, right, where is 360 minus? So 360 minus, I can always write this here. 360 is going to be here. 360, this is 0 or 360. Right, so it's going to be 0 plus. Going here, it's going to be 0 plus. Then here, it's going to be 360 minus. Right, so 360 minus is in quadrant 4. And here, it's only cos that is positive. So it means that tan is going to be negative. So I will have equals to my sine of x times minus, it's going to be minus, right, into minus your tan of x, right? I can just put square brackets here, times, how can I write sine 450? Okay, I will come back to this for now. Minus x plus your cos of squared x minus 180 degrees. So what I'm trying to do here, I'm trying to not confuse you as much. I'm trying to write everything step by step, right, so that you have a good understanding of what you are doing, right? If we simplify each, right, you don't have to rush. It's 8 marks. Usually if it's 8 marks, you have to spend 8 minutes. If you can spend less, then that's good. So it's going to be negative times negative. It's just going to be tan of x, right? Then sine of 450, right? So I can write sine of 450 as times sine, right? Sine 450. So if I come here, I can write 450 degrees, right? So let's just try to come here a bit. So my 450 degrees can also be written as my 360 degrees plus 90. Right, so that's what I'm going to do. Right, so now I will have 360 degrees plus 90 degrees minus x, right? But now I'm going to put this into brackets. So it's going to be the same thing as 360 minus x, right? Then plus my cos of squared into x minus 108, right? If you can do it quicker than I am, then you are more you are more than welcome to do that. But the reason I'm doing this is so that even those that don't understand get to see how we solved each and every term step by step, right? So now I will have my sine of x times your tan of x. So I have 360 plus, so 360 plus is going to be in the first quadrant, and everything in the first quadrant, it's just positive. So this is going to be your sine of 90 minus x, right, plus my cos squared x minus 180 degrees. And then from here, what I can do is I have my sine x times, I can also write this as sine of x over your cos of x times sine 90 minus, right? So 90 minus will be in the first quadrant. So this is a cofunction. It will change and become your cos x plus I can say this is going to be minus your cos squared x into, it's going to be your minus cos squared, right, into 180 minus x, right? Let's just use your square brackets. And then from here I know this and that will cancel, and then sine x times sine x is going to give me sine squared x, right? And then from here I have cos, right? I will take it as cos 180 minus, right? So where is 180 minus? 180 minus is in quadrant 2. And how is cos in quadrant 2? It's negative, because only sine is positive. So this is going to be negative times negative, which is going to give us a positive cos squared x, right? It's going to give us a positive positive cos squared x. But for simplicity purposes, we are just going to say plus, right, minus into minus, right, your cos squared x. I'm only doing this for those who may be watching later or looking at the notes, so that they also understand how we got to find some of the answers, right? So now I am going to have my sine squared x, right? Negative times negative is going to be positive. So now I'm just going to have your cos squared x, right? So sine squared x plus cos squared x is the same thing as 1, right? And then you get your full marks, which is 8 marks. And then you get your full marks. Right. So now let's look at the other question here. So the other question that we have, it's going to be your 6.2. Your 6.2. So they are saying determine the general solution of sine x minus 3 cos x is equals to 0. So we are just going to say sine x minus 3 cos x is equals to 0, right? So what I want is, I want a situation where I can have a tan, because I have trigonometric ratios that can divide each other and give a tan. Right, so I'm just going to have your sine x. So also with practice, it becomes intuition. It becomes intuition. If you do something over and over again, it eventually becomes better, right? And then here, I'm just going to divide by cos x. I'm also divide by your cos x, right? So in this case, cos x and cos x will cancel, right? Sine x over cos x is the same thing as your tan x, right? Is equals to 3. Right, so for my general solution, I will look for where tan is positive, right? So for my general solution, I will look at where tan is positive, and that is tan is positive in quadrant 3, right? Tan is positive in quadrant 3. But for me to get there, I need to find the reference angle. So I'm going to say tan x is equals to 3. Then x is going to be equals to my tan inverse of 3. And then from here, you can just punch your calculator. Your calculator should give you, let's see, 70. Okay, it's tan inverse of 3. Right, it's going to be 71.57 degrees, right? So this is your reference angle, right? And then how, if we are looking at our general solution, so tan is positive in 2 quadrants, right? It's going to be quadrant 3 and quadrant 1. Yeah, I may have missed that. So it's going to be quadrant 3 and quadrant 1, right? So in quadrant 1, the general solution for quadrant 1, so the general solution for quadrant 1, it's going to be x, right? X is going to be equals to the very same angle, which is 70, is just going to be 71,57 plus k, should be k times 0 degrees, and k is an element of integers, right? And then in quadrant 3, I'm going to have x is equals to 180. Quadrant 3, right? We are focusing on tan. Quadrant 3, it's going to be 180 degrees. So in quadrant 3, it's positive. So it's just going to be 71,57 plus this. And k is an element of integers, right? And it also can be your 180 plus 71,57 plus k times 180 degrees, and k is an element of integers. So either of these solutions will be able to give you full marks, right? Must not forget degrees. So either of these solutions should be able to give you full marks, right? Either of these solutions, and it's only 4 marks, right? It's only 4 marks, right? So now let's look at your 6.3, right? Let's look at our 6.3. So our 6.3, they are saying we need to solve for alpha if 2 root of sine alpha is equals to 1. And we are being told the condition there, right? Which is 90 and 270. So alpha should be alpha. So your alpha should be an element between 90 degrees and 270 degrees. So the way in which we are going to do that, we are just going to start by dividing by 2, divide by 2, and then we are going to have your sine of alpha is equals to, remember this and that will cancel, so I will have over 1 root 1 over 2, right? And then from there, I'm just gonna square both sides. So now I will have sine of alpha is equals to 1 over 4, right? And then from here, all that I need, right? All that I will need is going to be my reference angle. So I can say alpha is equals to your sine negative of 1 over 4, sine inverse. So my alpha is going to be, if I punch my calculator, I should be able to get 14,48 degrees, right? But it doesn't end there, because we were told that alpha only exists in 90 and 270, and this is out of range. So we need to find the relevant one. Right, so this we can also call your reference angle, right? So what we need to do here, we need, right, alpha within 90 degrees and 270 degrees. So the way in which we're going to do that, we're going to look at, remember we are talking about sine here, right? So we are going to look at sine. So there's two possibilities. It's either going to be quadrant 1, right? And quadrant 1 will not give us a range of 90 and 270 degrees, right? But quadrant 2, right, could give us a range of 90 and 270 degrees, right? How? Because then alpha now is going to be 180 minus the angle. It's going to be 180 minus the angle. Why am I saying 71? I'm already thinking about the other question. It's going to be 14 minus 48. It's going to be 14,48 degrees. So alpha is going to be 165,52 degrees, right? And therefore this is going to be the answer, right? Therefore this is going to be the answer, and it's within your alpha as an element of 90, to 70 degrees. Right, so this is how you solve that question. Quite fairly simple. So if you were watching this, or if you will be seeing this from YouTube, please don't forget to like, comment, share, and share the video. Right, thank you for joining until now. I will see you on another video.